The U.S. Infrastructure Report Card gives the nation's wastewater systems a grade of D+. Welcome to the Saving Our Sewers podcast, where we feature the practices, tools, technology, and ideas that will save our sewers. Let's get into it.
Quinn Peterson here, host of the Saving Our Sewers podcast, where we feature city leaders, innovative engineers, and infrastructure experts who are shaping the future of rapidly growing communities through smarter technology and data-driven solutions. This episode is brought to you by R.H. Borden, providing data-driven approaches to wastewater collection system maintenance. R.H. Borden helps collection system operators bridge the gap in funding, labor, and other resources with technology that eliminates wasted cleaning and CCTV efforts, automates manhole management, and dramatically reduces inflow and infiltration. You can learn more about how R.H. Borden is shaping the future of wastewater system management by visiting rhborden.com. Now, today, we've got a little bit of a different format. It's a panel presentation from the California Water Environment Association AC26 conference in Sacramento. This panel was on a new approach to manhole maintenance using manhole virtual models, also known as digital twins. The presenters on this panel are Jesus Barron, who you'll hear referred to by his nickname Buddha, and John Borden. Well, who is Jesus? He is the wastewater operations leader. He has 19 years of experience in municipal collection system, and he's currently at the Elsinore Valley Municipal Water District. Jesus is super knowledgeable and a lot of fun to boot. Now, John Borden is the president of R.H. Borden and the inventor of the manhole virtual model approach to manhole maintenance that this episode is discussing. So, without further ado, please enjoy this great panel discussion with Jesus and John.
Person of the year for his leadership and his contributions to the field. He leads daily field operations, prioritizing maintenance, emergency response, and regulatory compliance, while also managing infrastructure projects from planning through completion. Known for leading by example, Jesus builds strong teams and promotes a culture of safety and accountability. He also serves as the incoming Kirks Brooks Chair for the Santa Ana River Basin section.
Good afternoon, everybody. Thank you for that wonderful introduction. My name is Jesus Barron. I work for Elsinore Valley Municipal Water District. And today we're going to be talking about improvising manhole rehab decisions with LiDAR and 360 digital twinning and what we did at our district to assist us. So Elsinore Valley, we're roughly about 415 miles of sewer pipe. We have 36 actually lift stations. We have 3 treatment facilities that roughly treat about 7.2 million gallons of wastewater daily. We also have the recycled water production, assessment, and rehab challenges that Elsinore face, right? So we spent between $500 and $1 million in manhole lining each year since 1999. The maintenance team was struggling to identify and prioritize the highest needed manholes. We have roughly about 9,600 manholes within our system. And obviously, we have to try to do the level 1 inspection, right? Always of trying to assess whenever the crews are out there cleaning, and as well as when you do as well CCTV operation. So like I said, we have usually level 1, the assessment training, or, you're looking at it, you try to train the operators to look at deterioration within the manhole, degradation from the H2S or something that's maybe foreign within your system. One of the other ways that we've done is we had a 360 camera, on a stick. We've done different things. We also used our CCTV camera to actually lower the actual camera and try to just turn it around, right, with the cable. There's a lot of different techniques, as well as there's a lot of technologies now that are coming out where you can do manhole scanning. At this time, I would like to present John Borden from Borden, and he's going to explain what we were doing with R.H. Borden.
Good afternoon. Delighted to be here with Buddha, especially. I want to take you back on a little bit of a story that starts 3 years ago now. So we started doing digital twinning of the collection systems in 2018. By raise of hand, has anyone ever heard that term, digital twin? Raise them high, raise them high. Look around. This is exciting. There are people who have heard the term digital twin. That is fantastic. Digital twinning is something that has been around, I want to say, since the 90s, and it's getting more and more prolific in our day. We live in this day where the name of the game is find a data harvester, go collect data, beam it to the cloud, run it through an AI algorithm, and dispense knowledge and information and intelligence. That's the world that we live in right now. And in 2018, we started doing that for the collection systems. And we were specifically working on digital twinning of manholes and also some of the connected infrastructure, pipes, looking for blockages. And also we have some technology now that's pretty exciting for pinpointing exactly where I&I is in collection systems. This session, we're going to on asset management with manholes. So as we started doing digital twinning, we got to some customers who gave us a problem statement. They said, we want to develop this side of town, but unfortunately, we don't know what the dimensions of our pipes are in that part of town. Do you think you could help us measure the dimensions of those pipes? We said, sure. How do you do that today? They said, well, you harness the guy up, you give him a tape measure, you send him down the hole with a clipboard, and he writes down the dimension of the pipe when he measures it with a tape measure. We thought I wouldn't want to be the guy on the end of the tether. Has anyone ever gone down into a manhole and measured a pipe just by raise of hand? Bless you, bless you, bless you. That is a heck of a process. It typically takes 4 or 5 people for safety precautions to make sure it all goes well, and it takes a long time. And they said, we need to find a better way of doing that. So we investigated different technologies, and we developed this digital twin model. And the concept is take a high-density LiDAR scanner, send it down the manhole, and send millions of laser points throughout the entirety of that manhole and entirely recreate the manhole in virtual space. What we have here is a point cloud. This is the digital twin specifically of the manhole that was scanned. Now, what can you do with a digital twin? You can do some pretty cool stuff. Number one, you can measure the pipes without going in the manhole. That's nice. What you do is you pull that digital twin up, you have a little measurement tool on the computer, you go in virtually and you measure the pipe. And it's actually even more accurate than if you went down with a tape measure because the lasers are within 1 millimeter and an operator with a tape measure only measures to the accuracy of a tape measure. So digital twins of manholes have some really powerful attributes, primarily for dimensional accuracy. The second thing that we can do with digital twin is we can create a video. So this is a 360 video that goes along with the point cloud. And in that, you can virtually go into the manhole and see what's going on. Now, again, from those who raised your hands, I could tell that there were several of you who have personally been inside of a manhole. If you had to give a score from 0 to 10 of how enjoyable it is to be inside of a manhole, where would you score it? We got a thumbs down over here. Right? So there's a lot of hazards, as we all know, going inside of a manhole. We want to keep our staff out of the manhole. Now, sometimes when there's physical rehabilitation that has to happen or manhole replacements, obviously we got to do that physically. But when it comes to assessment, let's send down a probe. Let's not go down there ourselves. So what we're doing is we're creating a virtual world in which we can manage all of our manhole asset infrastructure. Now, we want to put you in this room, all those who are in this room, inside of a manhole. So what we've done is we have a VR headset. What Army has right here is a VR headset. Simply put it on your face and enjoy the ride. You will be lowered into a virtual manhole. And throughout the remainder of the session, you can get that sensation. Now, what does that do for us? We can inhabit the manhole virtually without the hazards, so there's a lot of safety precaution or safety benefits to doing that. But there's really 2 primary use cases for the VR headset. Number one, city councils. If you've ever gone in front of a city council and requested budget where you're competing with the city park, it can be difficult. If you have a manhole that's out of sight, out of mind that needs funding versus the park, a lot of times they will go with the park because they can see it. When crumbling infrastructure is unseen, it's difficult to fund. So what this does is it helps the city councils actually inhabit the infrastructure that they own without having to send them out into the field. The second one is for training. So if you have staff that need the experience of going inside of a manhole without going inside the manhole, that's totally the way to do it. So we're twinning and getting these different ways to view manholes. Again, dimensionally, and also this other with the videos. Now, when it came to working with Elsinore Valley, we met with them. They had almost 10,000 manholes. Now, manholes are constantly getting eaten up by hydrogen sulfide. But the question is, which manhole is falling apart or which manhole is getting eaten up and how fast. It's difficult to quantify the amount of degradation going on inside of a manhole, especially if you're relying on an operator to go give their opinion. They'll open up the lid, they'll look inside, they'll say, this one doesn't look too bad. They'll open the next one. This one might be bad. So it's very arbitrary if you're using an individual. However, if you have a digital twin, you can tell quantifiably the difference between degradation. What we're showing right up here are 3 different manholes. One on the left, you can see not a whole lot of deterioration. The middle is fair, and the one on the right definitely needs some review and further investigation. So what we can do now is we can scale programs of manhole asset management so that we can quantify degradation for those programs. So we can put a quantified score at scale. No more operator interpretation, no more reports to fill out. Just take the scan, run the algorithm, and it'll score the manholes for you. I want to pass a microphone over to Buddha just to give any commentary at this point, and then we'll continue on with the technical piece.
So one of the things that we did in Elsinore and we would rely on is a tribal knowledge. And I know that there's a lot of great operators out here right now, and you guys do the level 1 inspection, right? You visually look at the manhole, try to assess it. One of the cool things that we liked about this program was with the LiDAR, it gives you a wall score, right? So it'll tell you and give you and take the guesswork actually of being able to say, okay, this manhole needs to be on our CIP project or whatever your agency is doing in terms of rehab, right? And you're able to identify that a lot faster. There's no guessing work through it, right? So it's all that's removed for you. So right here, this was our pilot program right here. My superintendent and I identified some manholes that we wanted to get scanned that we had already on a running list that we had. Again, that list was built on just tribal knowledge, just operator knowledge that we've gone and we've cleaned through the system. You know, one of the things as an operator, right, when you're hydrojetting and the shelves, the channels, you're just tearing it apart, right, with the pressure. And we identified those. So those were the ones that we did on this pilot program. By show of hands, how many people have gone through and seen and let your upper management know, hey, we have issues in our system, you know? Good portion of you guys. So we were trying to eliminate that right now. So the guessing work was taken out by doing this. Okay, so right here we did the pilot. It was 20 manholes, right? We initially did that. That's how we started this. 50% of those that we identified needed a review, like he stated. So the degradation was really actually bad. And the other thing is, obviously, we did go back. We repaired these manholes, right? We gave them to engineering. They did a replacement on these. And then we actually had them come back, RH Borden, and rescan that manhole. And now we have what it started with. And it was actually, not replaced, it was repaired. So then we can actually gauge the thickness again, like I stated, the wall thickness, which is very much important.
So I want to just build on something that I think that Elsinore Valley did very well, and that is, how do you implement something new? As you come to these conferences, hopefully you're seeing things that are new, because that's the role of industry, is to bring new things to you as the operators and managers of the collection systems. So how do you do something that's new? And what we're seeing right here was the very first pilot that Elsinore Valley did, is they found a way to fund a small pilot, and they said, let's just give it a try. I would just encourage all of you, as the world rolls forward, more and more new stuff is coming faster and faster. In order to implement it, we start small, we make assessments, we pivot if we need to, or we persevere and continue down the line. And what you're going to see here as Buddha continues with the presentation is their model of implementation. So not only are we looking at the technology for the technology's sake, you're also seeing how to pivot into something that's new and foreign, has potential, but you don't quite know. So there's a lot of risk to it. So I just want to commend this team for doing that. And I think that's why he won this great award last week. One of the reasons, among others, is because we can't be afraid to implement something new, but we have to know how to do it. And it's typically pilot small, make assessment, and continue on. Just want to make that statement.
All right. One of the things that I want to say is, and add to that, is you have to have buy-in from your upper management, right? Which we did. They completely supported it. And as well as you want to make sure you spend your monies as an agency. They are taxpayers, right? That's how you get funded. So you want to make sure you put your monies correctly and address issues within your system, right? And so that was one of our key reasons why we wanted to try this, to see how it was going to work in our system. All right, so now, as I stated, we liked what we seen, so we went into phase 2. Phase 2, we actually we scanned 100 manholes from the list. 40% of those manholes that were scanned also needed some assistance with them, right? So if you actually see here, there's actually a neat dashboard. This is part of it right here. And all the manholes that were scanned, and then they're color-coded. So the red ones were real severe. And based on here, so of the manholes that were scanned within this area that we gave RH Borden to do, 48% needed a review, right? And we knew that in a sense, but we wanted to make sure, we wanted to see what that their technology could do for us, how it would be beneficial to us as an agency. One of the other things that we actually asked for was we requested for them to insert the diameters for us. So that was upon our request. That was something that my superintendent wanted, and they were able to achieve that. And so, like you said, it's pretty precise.
So having a digital twin opens up a lot of new doors. As Buddha's showing right here, not only do you have the video, you've got the point cloud for interpretation, but now we're doing dimensional analysis. Now, what this leads into, which we won't have the chance to talk in this session, but who was here just in the prior session with SmartCover by raise of hand? SmartCover was talking about this technique of discovering I using Manning's formula. Well, in order to get Manning's formula to work, you need the dimensions. How do you get the dimensions inside of a manhole? Right here. So when we start to couple up technologies, these digital twins start to play off of each other, and it makes this huge opportunity for us to develop not only manhole degradation assessment, but also I. So this is complementary to that whole trend of data harvesting in the collection system.
So one of the things that I want to point out, as you can see on the left-hand side right now, this video is playing. You can see what it was. Visually, it doesn't look that great. However, the video on the right didn't score bad, correct? But visually, if you look at it, it's like this needs to get fixed, right? But it still has wall thickness. So the wall score was good actually on that one. So right now we actually have the program is now working so we have engineering behind us, backing us, and so they budget so much money a year, right? And we started on the north end in a community called the Horse Thief Canyon area. It's south of Corona off the 15 freeway. And we scanned 377 manholes this last month. The RH Borden team came out, and they were here roughly less than 2 weeks. They were able to do that, and then they give us a deliverable. They let us know when it's available on the internet and on their platform, and then we can go back, and then my superintendent and I will look at them based on the colors, like I showed you earlier, that which ones were really bad, and then we could start building the list off of that. So now we can focus our monies on manholes that truly need to be rehabbed or replaced.
I wanted to just build on that, what Buddha was talking about, that the field work and the data analytics were done as a service. This is, as you can tell, it's not a simple or exercise to take point clouds, beam them to the cloud, and then run wall analysis on them. Like that's the specialty that we can deliver as a service. But what needs to happen is digesting that and taking action. So as we look at our industry and the staffing status of the industry, the staffing is under pressure. I think the statistic is that in the next 5 years, is it 20% or more of the staffing is going to be retiring? Well, think of all the knowledge that's going to go away with that and the pressure it's going to put on everyone who's left. So our ability to team up together is going to, I think, be very important on successfully managing these systems. So again, the way that Elsinore Valley did that is they leveraged the field work and outsourced, but then they are managing actively, very actively, the data. And that data is what really has the gem and the value inside of it.
Okay, this is, like I was talking about, this is our Horse Thief Canyon community that we just scanned, right? It was 373, we scanned that. Of those manholes, 96 received a good score. So now we have that data. That data is stored there. They're all green. And that's not just green because their manholes are identified as that. For us, they're green because they have a good score, right? So they're all good. There's a couple that are yellow, but nothing in red, which is a good thing. And we'll come back in a couple years and redo this whole area. It'll get done, and then you can compare the data from when we did it this year to whenever we decide to do it in that year, and see how much degradation has happened within the manholes, and how active we have areas with H2S that are attacking the manholes, and be able to address, but not just the manhole itself, but see why are we getting H2S concentrations in a certain area, right? Because you might see that it's close to a park. Why? Is it somebody dumping stuff in the park or in the track homes? So you can take your data and as well as be able to try to find out what other issues you're finding out within your system, not just what the manhole's doing itself. So like I said, it creates that baseline for you guys or for us, so we can go back and say, hey, a couple of years we weren't having this issue. This manhole was really good. What's happened that it's rated lower now?
So I was at the dentist the other day. You're wondering what this has to do with manholes, right? Did you know that dentists are now doing this? I have a crown right here. Sorry, I do. It's a little admittance. I have a crown. It has to be redone. And the dentist said, well, that's no problem. We can have you in. And before we pull it, we're just going to run a scan of your tooth. And then we will recreate another tooth using that. Oh, and that scan is called a point cloud. I'm like, you got to be kidding me. This is very cool. So this is actually very similar to what's going on in dentistry today. What are dentists looking for? Cavities. What are we looking for in manholes? Cavities. And not only are they looking for cavities today, they want to put things on a watch list, and they want to watch it over time. So essentially, this is one giant dental exam for our manholes. And we can take an inventory, and we can watch the cavities, and we can see how that progresses over time. So when you think manholes now, maybe dentistry would be in your future.
Okay, so again, like I've stated, Elsinore has started this program, and we're going to get through all our, we have it, I think it's set roughly about 10 years. Hopefully we can get through the whole system maybe sooner than that. And that's all based on, obviously, how much money we can get. So our engineering department right now is actively working with us. They're amazing. They'll budget the money, and then based on whatever monies they're able to secure for us, then they'll let us know how many manholes we're able to scan based on pricing. So that is our future right now. So excited because we want to see where we can start repairing our system or replacing manholes so that we don't have that failure and they can last another 50 to 100 years, That's one of the things. We do have the downtown Lake Elsinore area, which is we still have brick manholes, flat bottoms in that area, right? And it's lasted for a while, but it's bad now. So it's time for us to start going through. And right now they are actively replacing sewer lines in that area because back then there was we didn't have the standard of 8-inch sewer, right? And so we're replacing all the 4 or 6-inch that we do have in that general area for us. Now we're getting removing the smaller lines.
Okay, my turn for a candy bar. Not to eat, but to give.
He has a cavity already.
That's right. Sweet tooth. What percentage of the manholes in the pilot needed review? 50. 50 right there in the back. During phase 2, what percentage needed review? 48. Who said 48? Okay, right there. There's the 48. What percentage in phase 3 were good? Oh, man, it's candy for everybody. Nice job.
Right there, right here in the front, I heard him yell it out.
So what is this telling us? It's telling us that we are in this positive spiral. Data does this for us. When it's properly presented and you take proper action, it actually becomes a positive spiral. You're able to attack the worst ones first with data, and then the next iteration gets better, and the next iteration gets better and better and better. Every time data is properly implemented, you get what's called orders of magnitude improvements, and it's because we're properly using data. This is a great case study of how can we use data to get those big gains. There are other technologies out there that can help us do that. It's in the digital world that we get those big gains. So just wanted to call that out.
Okay, I would like to open it up for questions. We got done a little early, but it's okay. We're going to have open discussion. If you guys have any questions for me, for John, I'd be more than happy to answer those for you guys.
What is the point cloud detecting for the classification? Is it the difference between the ID of the manhole from a certain amount, or what is the red?
Great question. So what we're doing is the laser, an individual laser point will go and it'll bounce off the wall and come back, so you'll know exactly the distance of that one laser. We then take that and compare it to a reference. So in a precast manhole, we're comparing it to 48 inches. That's the typical barrel of that. If it's off, if it's degraded, it'll turn red. If it is sloughing, it'll turn blue, meaning it'll come towards the inside. So if you go to scan a lined manhole, typically you have some thickness and the whole thing turns blue. But it is going against that reference, the initial reference. Now that's on the very first scan. The next time we scan, so Buddha mentioned that we're going to come back in a couple of years and check again. You can use the prior point cloud as the reference and just check your current to the prior. At that point, you're checking not only the barrel, but you're checking the cone and the trough and everything. And that's where, anyway, it is checking to a reference. Great question.
So with that, are you projecting forward then via your asset management plan?
Absolutely. Okay. This is now predictive for sure. We're able to get a new term called degradation velocity. It's the speed at which things are degrading.
So 2 questions. Can you get inverts and measurements on that when you're doing it?
Absolutely.
That's big for us, right? Especially during new construction. And secondly, are you guys using MACP or how are you guys coding?
That's a great question. I don't know. Was that a similar question that you had, gentlemen? So MACP, first question, how many here are certified with not only LACP and PACP, but MACP as well? Okay, so been through the class. This is not MACP. We can use the video to generate an MACP report. Sewer AI, and so there's others that can ingest that and they can translate that into a PDF report. One of the reasons why we do this slightly differently is the ability to scale and the deliverable. We want to be able to scan thousands of manholes, have them automatically turn red, yellow, or green based off of the algorithm, and then take action. So this, in a sense, leapfrogs the MACP, although MACP can be generated if it's necessary. So MACP can certainly be generated. I think for this methodology, it's not necessary. So some of the smaller municipalities that may not have certified operators, this can be a great tool for them. But for the larger municipalities that require MACP, we can generate that for sure.
Just 2 questions. How long does it take to average to scan one manhole? And then is there any plans to maybe LiDAR scan pipe instead of just manhole?
You can see where that's going, right? Manhole scan takes about 15 minutes. So it's a very mobile operation. Scanning the pipe is certainly possible. We're not currently doing it, but you can see where things are headed when you're able to do stuff like this. Yeah.
Quick question. When you did the 2-week pilot program, how long was the turnaround?
Turnaround, when we got the deliverable, I think it was about a week total from when they got the information, they got it back to us. So in 2 weeks, they scanned and gave us the deliverable and we were able to see it. However, we did hold back and because they wanted to come down and show us with the Oculus and everything else. So when we actually seen it, it took a little bit longer. However, they turned around and they got the stuff done to us fairly quick. It was only 20 manholes, right? The other ones is going to take a little longer, but it's still very quick. You're still within, like I said, we did the 373 manholes in the horse thief area recently. We haven't received the deliverable, but that's a little bit more. But again, the beauty of it is being able to use their dashboard and you see all the information and all those manholes that are on there. Good question. Do we have any other questions?
You get the color-coded rating on the walls. When the LiDAR would get into the channel, you see that kind of grays out. Obviously, you don't have a consistent dimensional reference to give you that color-coded rating, correct? So is that where you guys lean on the video, and does that play into how you rate the manhole? Can you put a value in the system that helps you rate that manhole? Because the channel is obviously a massive part.
It is for sure. And yes, that is why the video does come in super handy for assessing those. The So this is a good example on the right-hand side. This is the first time we assess it. We can compare it to a reference of 48 inches. Because all of the troughs are custom based on what's going on in the trough, we can't score that using the algorithm the first time, but the next time we scan it, we can totally do it. Yeah, so it's assessment 1 and assessment 2, and thereon after we've got the baseline copy, we can always compare it to its prior scan.
So my question is kind of going to piggyback on what you guys just heard is we're not assessing the full chimney and we're not assessing the base. Why are we not assessing the base when that's the mother load, right?
Yeah, so the video captures it on the first scan. The second scan, it'll do all of it because we need that reference. So the reference for this manhole, we know, again, that 48 inches because it's precast should be the first time reference. But next time, we'll know all the dimensions because we'll have this as our scan and we can compare it to itself next time. So the next time we scan this, we'll see the entire thing. This is a really good point, though, too, is if we look at the behavior of hydrogen sulfide is heavier than air, typically works its way up from the bottom. What we're seeing is definitely degradation from the bottom up. The first as analysis will show us how impacted is that overall manhole. And if we're looking at something on the far right, it typically means we got degradation down there on the shelf and in the bench as well. So we are using that as a first-time indicator that it kind of indicates the condition of the rest of the manhole. So we are extrapolating the score using the barrel as our scorecard, but it really does tell the condition of the entire manhole. When a manhole gets eaten by H2S, the H2S is not picky. It eats everything. Yeah.
It looks like you have a pretty good definition of where the barrels start and stop there. How did you determine when you were scoring this or reading this where one barrel started and stuff?
That's a good question. So that's an automated algorithm that does that. It's looking for the curvature change. So when we start to get curvature at the bottom or curvature at the top, that's where it stops. This is something, again, we want to implement at scale. We're scanning thousands and thousands of manholes to try and keep the cost really low. And so we have to automate that. And so what it's doing is it's climbing up the barrel, looking for a change in the diameter, and that's where it stops. So it goes up as high as it can. Yeah. I think yes, thank you. Your hand's been up for quite a while.
Have you tested this out on, Lake Elsinore is a more relatively new area, mostly built up, I think, probably in the 1990s to present. So it sounds like almost all of your manholes are precast concrete. Is that right?
No, actually, Elsinore was built in 1896, somewhere around there. And downtown I have an old downtown sewer map that was hand done by the last director of operations. We have it up. It's all done by hand, and it's all the manholes and the cleanouts in that downtown area. That was 1906 when they started that. So we have that still in the archives.
Well, have you used this on the brick manholes?
Have we used this on the? We haven't gone into downtown itself, but it is slated to be videoed. The manholes that we started with the pilot was some of them were in downtown that actually scored really bad, but the brick manholes were not part of that. We wanted a target where we had the big trunk line, and that's where a lot of those. This is a major trunk line. This is a 27-inch trunk line going to our treatment facility. So this was attacked really hard. So we wanted we wanted to get an assessment on those manholes specifically because we knew that when the crews have gone through, they keep bringing back a lot of aggregate, right? So we knew that they were deteriorating. We knew that they're really bad. So we wanted to make sure we addressed those first. And then now that we've started the phases, the ones in downtown are on the list and will be scanned. But that's a good question.
So although we didn't scan in Elsinore, we've scanned tens of thousands of these, and many of them are brick. It's interesting because brick will deteriorate differently than precast. Precast has the sloughing and the degradation problem that we've shown up here. Brick will lose a brick, and so you'll actually just see a hole sitting right there, or the grout will start to degrade and it'll let I&I in. So the signature that the brick gives off is different, although it can certainly indicate we can see the degradation on brick the same as we can with precast. Great question. Yeah,
Are you guys replacing these manholes, or are you guys lining them when they're finished? Like, what's the rehab on them?
So the rehab, they are getting lined. Okay, we are lining the manholes after they get whether they're replaced or they're repaired, and then they're lined.
The data formatting that you're receiving, can you integrate that with any other program like your CMS or a condition assessment program?
Yeah, so the data is held in ArcGIS, fully exchangeable with any other platform. It's not proprietary. There's no license cost. It can be all exported in a CSV or in a shapefile and easily imported into any platform. Yes.
And that's all the data that you get from this?
It's all the data. The animations that we're looking at are they're links, and it's all held on AWS, on Amazon. But those links can be exported anywhere, and as soon as you click the link, it turns on the video. So you can download all the point clouds. It's all available. It's not proprietary. So yes, it's fully exchangeable with any platform.
Those point cloud files can be very big.
Yes, they can.
Are you guys only scanning manholes right now, or are you doing other structures such as more of a rectangular structures, wet wells, other facilities?
We've done everything, even up to a digester, and that was fun. So yes, we typically we focus on manholes. That's the primary, just because that's the majority that are out there. But we do wet wells. We've done lift stations, and we've done digesters. So yeah, we can do it for all of them.
How much does the pilot run? Okay, you guys did a 20 manhole pilot, obviously not buying the equipment, that kind of stuff, because I'm guessing the equipment's super expensive. But how much was the pilot? So if anybody's interested in doing this, how much would it run us?
I'm gonna let you. I don't recall what the pilot cost, but it was. He did it for It was reasonable where our management said, let's try it. But it was, I don't want to give you a number because I don't recall what it cost.
Come talk to me afterwards. We'll talk numbers.
Thank you, guys. I appreciate you staying in my presentation. You guys were a lot of fun.
Thanks for listening to the Saving Our Sewers podcast. We'll be back next time with more insights you can use. Be sure to click and subscribe to get future episodes.